everyone, welcome back to my video. My name is Tasya Natali Sihombing. I am college student from Mathematics Education Study Program 2019 at State University of Medan. In this video, I will explain about Chapter 5 is Babylonian Mathematics Development. Okay, I will start. Babylonian mathematics is mathematics invented in Mesopotamia 2,500 years BC in the Babylonian civilization. Babylonian mathematics refers to all mathematics developed by the Mesopotamians in what is now Iraq. The Babylonians were the first to write numbers from left to right. This is advanced by the number of tables found written from left to right. The Babylonian mathematical system is sexagesimal, or a number based on 60. The number 60 has many divisors, namely 2, 3, 4, 5, 6, 10, 12, 15, 20, and 30, which make calculation easier. Okay, the first is the emergence of Babylonian mathematics. 2500 BC. The Pharaoh period is the period during which the Sumerian civilization was used by the Babylonians for phonetic writing. 2340 BC, the Akkadian dynasty writes mathematics in Akkadians and further developed the number system. In addition, this nation is the inventor of the abacus. 2100 BC all represent the establishment of the ancient Sumerian city as a capital now populated by Akkadians, as well as the high point of its bureaucracy under King Sulgi. 1800 years BC of Babylon, or Yue, is the supremacy of the northern city of Lower Babylon, Arcadia, and has the most advanced mathematical texts. The second is the development of mathematics in ancient Babylon. Babylonian mathematics refers to all mathematics developed by the Mesopotamians, now Iraq, from the beginning of Sumer to beginning of the Hellenistic civilization, named Babylonian mathematics because of the Babylonian religion's primary rules as a place to study at the times of the Hellenistic civilization. Babylonian mathematics combines with Greek and Egyptian mathematics to give rise to Greek mathematics. Then, under the Islamic Caliphate, Mesopotamia, especially Baghdad, once again became an important center for the study of Islamic mathematics. Contrary to the scattering of sources on Egyptian mathematics, knowledge of Babylonian mathematics was derived from more than 400 clay tables, except since the 1850. The slides were written in cuneiform while the clay was still wet and burned in a furnace or dried in the hot sun. Most of the known clay tables date from 1800 to 1600 BC and cover topics of fraction algebra, quadratic, and cubic equation, and the calculation of regular numbers, multiplication inverse, and twin primes. The slide also includes a multiplication table and a solution method, linear equation, quadratic equation. The Babylonian plates 7,208 non-BC give an approximation to which is accurate to 5 decimal place. The third is the Babylonian number system. The Babylonian number writing system was known as cuneiform, from the word cuneus, which means light or spilled, and the word forma, which means form. Babylonian writing and numerals are often referred to as cuneiform because they are shaped like nails. The Babylonians wrote cuneiform using an elongate triangular shaped sticks triangular frames by pressing it against a wet clay plate to produce a tempered triangular depression resembling a nail. Unlike those of the Egyptian, Greek, and Romans, the Babylonians numeral used a correct place-value system in which the number written in the left column represent the large values. Okay, the Babylonian civilization in Mesopotamia replaced the Sumerian and Akkadian civilization. In the form of numbers used, the Babylonians in turn like idea from the Sumerian, namely the sexagesimal number system or base 60, due to the Babylonian prominence in astronomy. The 60 base system of calculation is still in use today. It is proved by the derivation of the number 60 seconds for 1 minute and 60 minutes for 1 hour. The reason why the number 60 is used is because this number is the smallest number that can be defined by the first 6 digits, namely 1, 2, 3, 4, 5, and 6. Another reason is that the number system was widely used by humans today in the decimal system, which is a system based on 10. The Babylonians wrote cuneiform using an elongate triangular shaped stick triangular frames by pressing it against a wet clay slab to produce a pointed hollow like a nail. The following is an example of writing symbol for the Babylonian numeration system, namely this. Look at this picture. Symbol image created from two symbol system. The Babylonian used 1 to represent 1, 2 to represent 2, 3 to 3, and so on up to 9. However, they tend to organize the symbol into neat chart. Once they got to 10, there were too many symbols, so they turned to make different symbols. 11 is 10 to 1, 12 is 10 to 2, 20 is 10 and 10. For the 60 symbol seems exactly the same as the 1. 61 is 60 and 1, which therefore looks like 1 and so on. Okay, the fourth is number theory of the Babylonians. In the age of the Hellenistic civilization, Babylonian mathematics combines with Greek and Egyptian mathematics to give rise and Greek mathematics. Then under the Islamic capital like Mesopotamia, especially once again become an important center for the study of Islamic mathematics. Contrary to the scarcity of sources on Egyptian mathematics, knowledge of Babylonian mathematics was derived from more than 400 clay tablets excavated since the 1850. The slabs were written in cuneiform while the clay was well wet and burned in a furnace or dried in the hot sun. Some of them are homemade work. The earliest evidence of the written mathematics is the work of the Sumerians, who built an ancient civilization in Mesopotamia. They developed a complex system of metrology as early as 3000 BC. From about 2500 BC onward. The earliest tracker of the Babylonian number system also referred to this period. Most of the known clay tables date from 1800 to 1600 BC and cover topics of fraction algebra, quadratic and cubic equation, and the calculation of regular numbers, multiplication inverse, and twin primes. The slab also includes multiplication table and method for solving linear equation and coordinate equation. Babylonian mathematics was written using the hexadecimal base 16 number system. From this define the use of the number 60 seconds for a minute, 60 minutes for an hour, and 60 times 6 degrees for a circle, as well as the use of second and minutes on a circular arc which represent fractions of degrees. Also, unlike the Egyptians, Greeks, and Romans, the Babylonians had a true place value system where the numbers written in the left columns represent the last value as in the decimal system. Babylonian numeral system or 2000 BC, the first people who recognized the number 0 were Babylonian. The 5 is advantage and disadvantage of the Babylonian number system. Advantage of the Babylonian number system. The first is recognized building form. The second is determination of the value of the square root. The third is has demonstrated the Pythagoras theory. The fourth is measuring an area and volume. B. Disadvantage of the Babylonian number system. The first is don't know 0. Second is not familiar with commas to make decimal numbers. The third is don't know the negative sign. The fourth is addition, subtraction, multiplication, and division are still unclear. Next, investigation relating to Babylonian mathematics. H. Field geometry. Geometry was used by the Babylonians from 2000 to 1600 BC. B. Field of algebra around 2000 years BC. The development of algebra is not only able to solve quadratic equation but also dispute solving third and fourth power equation. C. Hexadecimal number base 60. Babylonian mathematics was written using the hexadecimal number system base 60 because of its superiority in the field of astronomy. D. Plimpton 322. This system first appeared around 3100 BC, known as the positional numeral system, where the value of a particular digit depends on the number itself and its position in the number. The seventh, Babylonian mathematical letter, the Trinian script was used in the manufacture of the Babylonian letters. The plates are written while still wet and then graved on burnet. There were 4 blackboard fonts, namely, the first is Yellow CBC 1209, board the Yellow UBC 7289, board is a board on which a diagram is drawn in the shape of a rectangle measuring 30. The Yale mirrors 200 BC contain N3 and N2 tables for solving equation, including cubic equation that lead to simulation equation leading to particle equation. B. Plimpton B 122. Plimpton 322 is a board number 322, which is the result procession Asian Mesopotamian manuscript written by J.R. Prenton containing mathematical problems. C. Susa board. This board shows how to calculate the radius of a circle through an equilateral triangle. D. 3D board. This is D board display a geometric problem that asks for the dimension of a square whose area and diagonal are known. Okay guys, that's all from me. If you have question and suggestion, you can write in column comment. And don't forget to like, subscribe, and share this video on your social media and turn on the bell to know notification for my next video. Thank you. See you on the next video. Bye-bye.